the restless star in Orion. Human nature often leads us to overlook cosmic phenomena until they become pressing or potentially dangerous. This observation, though simple on the surface, reflects a profound truth about the way people relate to the wider universe. The sky has always been above us, a constant, unchanging background to daily life. Yet our attention only shifts toward it when something disrupts the ordinary, something that makes us pause, feel awe, or sense danger. Most of the time, we ignore it, allowing the heavens to fade into the backdrop of human preoccupations. And yet, when instability arises in the stars, when trembling light patterns reveal sudden changes, our curiosity awakens. It is as though the universe itself must shake us out of complacency before we notice. One such example is Betelgeuse, a massive star in the constellation Orion that has recently begun to show signs of instability, trembling in a way that suggests something significant and potentially ominous may be unfolding. For centuries, stargazers have admired Orion, its belt of 3 bright stars, and the fiery red shoulder that distinguishes it. That shoulder is Betelgeuse, better known in common pronunciation as Betelgeuse, a red supergiant whose size and brilliance have made it legendary. Today, however, this familiar giant is not as steady as it once appeared. Its fluctuations, its shimmering uncertainty, signal that it is in the midst of deep changes. Such changes are not trivial. In the lives of stars, instability can be the herald of cosmic transformation. This opening reflection captures both the awe and the neglect humans often display toward the universe. On one hand, there is wonder, awe at the vastness, the fiery beauty, and the intricate machinery of cosmic order. On the other hand, there is neglect, an almost careless dismissal of the significance of stellar processes. We marvel at the stars, yet forget that they are alive in their own way, undergoing birth, growth, and death. Human beings rarely concern themselves with stellar evolution, not unless it begins to affect what we see. The paradox is striking. We are small inhabitants of a fragile world, and yet the mighty workings of the cosmos so often escape our concern. The cosmos is always in motion. Galaxies collide in majestic, destructive dances that take millions of years to unfold. Black holes devour matter and even light, reshaping space-time itself in their immense gravitational grip. Planets orbit their stars, bound by invisible threads of gravity, each tracing paths that repeat for eons. Stars, those blazing furnaces of nuclear fusion, live out their life cycles, from fiery birth in nebulae to steady midlife burning, and eventually to violent or quiet ends. This ongoing rhythm of creation and destruction defines the universe. Yet despite its constant dynamism, for most people, the sky is simply a background, a quiet canvas above their heads. It is the roof of the world, rarely scrutinized except on nights of clarity or occasions of spectacle. Only when something unusual happens, like an eclipse, a meteor shower, or a star behaving strangely, does the collective human gaze turn upward. Ancient civilizations watched the skies constantly because they believed their fate was written there. Eclipses frightened kings and peasants alike, thought to herald doom. Comets were seen as omens, fireballs of prophecy streaking across heaven's canvas. Today, with modern science, we explain these phenomena with rationality, yet the instinct remains. We look when the unusual intrudes upon the ordinary. Betelgeuse, as Betelgeuse is commonly referred to, illustrates this truth perfectly. The case of Betelgeuse, commonly referred to as Betelgeuse, illustrates this perfectly. Normally, it is just another bright star decorating Orion's shoulder in the night sky. For millennia, it has been an anchor point for navigation, mythology, and seasonal change. But recently, its fluctuating brightness and signs of instability have made astronomers pay close attention, and with good reason. Betelgeuse is not just another star. It is a red supergiant, a colossal celestial body whose sheer size dwarfs that of our Sun, making our star appear minuscule by comparison. To say that it is big hardly captures the truth. If Betelgeuse were placed at the center of our solar system, its surface would extend past the orbit of Jupiter. This staggering scale makes it one of the largest visible stars to the naked eye. Its mass and energy output are immense, and though it resides far away, it asserts itself powerfully into our view of the night sky. Located over 640 light-years from Earth, Betelgeuse' apparent brightness in our night sky belies its true distance. In cosmic terms, 640 light-years is a vast expanse. To imagine this, consider light itself, the fastest phenomenon we know, traveling at nearly 300,000 kilometers per second. Even at that unimaginable speed, it would take more than 6 centuries to reach Betelgeuse. This means that when we see it today, we are seeing it not as it is, but as it was 640 years ago, long before telescopes, before Shakespeare, even before Columbus set sail. We are looking back into history, peering into the medieval skies preserved in photons that have only just arrived. With today's technology, realistically, it would take over 12 million years to cover that distance using conventional spacecraft, a span of time far exceeding the entirety of human history. No human civilization has lasted more than a fraction of that. From the rise of agriculture to the digital age, only 12,000 years have passed, a blink compared to 12 million. The immensity of the gulf reminds us how isolated Earth truly is, how bound we are to our home planet and its neighborhood. And yet, despite that remoteness, Betelgeuse looms as a presence in our sky. When placed in this perspective, the extraordinary magnitude and power of Betelgeuse become clearer. Even from so far away, it appears as one of the brightest points in our sky. This means its true luminosity must be staggering, since only a fraction of its actual energy reaches us across those 640 light-years. Imagine a lantern so powerful that even if it were placed halfway across a continent, you could still see its glow. Such is the case with Betelgeuse. Its brilliance pierces the void, telling us of its size and energy. The very fact that we can see it so clearly highlights just how massive and radiant this star truly is. Betelgeuse has been exhibiting intense trembling and instability for some time. To the casual observer, stars appear serene and steady, twinkling softly in the night sky. But this is an illusion. They are anything but calm. Inside, immense nuclear reactions rage with unimaginable intensity. Their surfaces boil with turbulence, and their cores churn with elemental fusion. Stars are dynamic systems governed by complex physical processes, many of which remain difficult to fully simulate or predict. Scientists have long studied Betelgeuse due to its pulsating nature. It is classified as a variable red supergiant, meaning its brightness fluctuates over time. These pulsations are driven by internal mechanisms that cause the star's luminosity to vary in cycles, ranging from tens to thousands of days, depending on whether it is expanding or contracting. These variations make Betelgeuse an object of intense interest, particularly since its changes in brightness are unusually pronounced compared to many other variable stars. Astronomers have observed its magnitude fluctuate between 0 and 5, a remarkable range that reflects the star's volatile nature. Betelgeuse's brightness variations follow specific cycles. The shorter cycle lasts approximately 185 days, while the longest spans over 2,300 days. These cycles can be measured with great precision and have offered astronomers critical insights into the inner workings of the star. In February 2021, for instance, the star's V-band brightness dropped to 1.1614, one of the lowest levels recorded in years. This anomaly deviated sharply from its historical pattern. The sudden drop triggered concern and led to further observation, as it hinted at deeper changes occurring within the star's structure. What could have caused such an unexpected dimming? Dust clouds expelled by the star? Internal disruptions? Theories abounded, but the underlying truth was clear: Betelgeuse was not stable. The striking red hue of Betelgeuse adds to its intrigue. This distinctive color results from a relatively low surface temperature of around 3,500 Kelvin, significantly cooler than the Sun's surface temperature of approximately 5,500 Kelvin. Despite its massive size, this lower temperature means Betelgeuse emits less energy per unit area than our Sun. Paradoxically, however, because of its enormous surface area, it still appears extremely luminous from Earth. Its red glow is both beautiful and foreboding, a sign of the advanced stage of its stellar life. What makes the current situation more alarming is that Betelgeuse, while typically stable for a red supergiant, has recently transitioned into a more volatile phase. This shift is believed to be tied to changes in its core. As with all stars, the fusion of hydrogen into helium fuels Betelgeuse's energy output. However, in red supergiants nearing the end of their lives, the hydrogen in the core becomes depleted. This depletion causes the star